Okay, so in this video we're going to look at the sample exam and we're going to look at the partial differentiation question. Down at question, this guy here, question 3. Right, so just go to the new screen. So the integral of big fraction and the three factors laid out first in the bottom. Right, so the first thing, the way that we kind of do this is we say, right, well, we want to integrate anyway, but we're going to have to we're going to clean this. We're going to make this expression, this big fraction on the inside, more manageable, so that we're going to split it up into little individual fractions where we can integrate each of them separately easily. Right, so that's the first part of that's going to be the first thing I'm going to do. I'm going to say split the inside, split into partial fractions. So the idea is I'm going to write the original fraction, or if I kind of call that the old fraction, and then the new fraction over later. So 6x squared, I'm just going to take it down again, minus 19x minus 6 over x minus 2 by x plus 3 by x minus 4. That's my old fraction, and I want it to look like this new sum of fractions. A over the first factor plus capital B over the second factor in the bottom plus capital C over the third factor in the bottom. Right, now to make all this work, I need to find the values of A, B, and C that make that work. Now, to do that, I'm going to, in a funny way, I'm going to re-add up all these individual fractions. I'm going to combine them back into one again, sort of in a way doing what I don't want. I don't want a big ugly fraction, but I have to do this to find the values of A and B and C that make this split work. Now, what you're going to do is you're going to use, if you have it memorized or if you're still memorizing it, how to add up three fractions in the one go. So I need this formula here. If I have A over, I put it like this: A plus B plus C over the three bottoms D, E, and F. How to add them individual fractions up in one go? What you do is you say, right, the result is one big fraction, and it's A over the other bottoms EF plus B over the other two those other two bottoms DF plus, extend that, plus C over the other two bottoms, D and E, all over the three bottoms stuck together. Right, so that's what I'm going to do with those blue fractions up above that there. Now, but I'm just going to I'll try, if I can see, I'll try and keep that on the screen, but I probably can't now. I might have to move it down a little bit, but we'll see what happens. Right. Just going to move that down a little bit. Okay. Sure, we'll keep it a bit on the screen. Right, and we'll move it down again. Right, so underneath that I'm going to say, well, when I add these separate fractions back up again, I'll get A by the other two bottoms, x plus 3 by an x minus 4, plus B by the other two bottoms, x minus 2 by x minus 4. What's going to happen now is I didn't leave myself enough space to do all this in the top line. I just move that over a little bit, plus C by the other two bottoms, x minus 2 by x plus 3, all over the three bottoms multiplied together, or if you want to even think of it as stuck together, because they're just factors separated out by brackets, x minus 4. Right, okay, so split that into fractions and we added it back together again. Right, but if I think of this is the old fraction that I don't want, and this is the new fraction. Right, I want those. I'm going to move that down as well. Right, just get rid of it altogether, I think. Okay, so I want this big fraction in the red to match this new fraction in the green, or underlined in green there. Okay, so, well, at the very least the bottoms match. So at least I have the bottoms matching. So that what's left to do is make the tops match. So I want, in a way, I want old top to equal old. If I think of that, that's old top and this is new top. I want old top to match new top. But as we done in class, it's easier if you just sort of say it lays it out. The question's laid out a bit better if you let the new top match the old top. So that's what I'm going to do. I'm going to say let the new top, which is this the big top with A, B, and C's in it. Here it is. I'm going to write the whole thing down. I'm going to say let that equal the old top, which is hidden out of screen. I'll bring it back up here just for 2 seconds. This old top here. Right. Okay. So I want this new top minus 2 by minus 4. The writing isn't great here, but I think you know what I mean. X minus 2 by x plus 3. Okay, I want that. I'm going to squeeze the old top and just on over in the left here. The old top. 6x squared minus 19x minus 6. Right, now the mission here is to find, I want A, B and C. I'm allowed to sub in, this expression is supposed to work for all values of x, and if you pick good, there's smart values to sub in here to really get rid of the A, B and C's one at a time so that you can find each one individually. And you don't have to think about it, well, you have to think a little bit about it, but it's given by those numbers and the factors. Think of it that you want to get rid of this first, then that there. Right, so looking at the first one, how would you get rid of that x plus 3? Well, if I sub in minus 3, that'll turn that to 0. But the side effect is when it's a good side effect, there's an x plus 3 somewhere else in the expression. So not only do I get rid of the a, I get rid of the c while I'm at it. So we'll do that first. So looking at that'll tell me what I need to sub in first. I need to sub in minus 3 first. But subbing in 3 won't work. That'll make it a 6. It's not gone yet. So that's the first thing I'll do. I'll change colour. Let x equals minus 3. So that means, well, you can take it down if you want. You can put down a by 0, but minus 3 by minus 4. But the whole thing's going to go to 0 anyway. So I think we kind of got used to that in class. And we said, we'll not even bother writing it. So what I'm left with is the only thing, 2 of the expressions, or if you want to put it like this, die off. One of them will survive. The one with no, this guy is the one that will survive because there's no x plus 3 there to go to 0. Right, so underneath that I'll say, right, b by, and I'll take my time when I sub this stuff in, minus 2 minus 3 minus 2 minus 3 minus 4 equals this. There's an x plus 3 there. When I put in a minus 3, that'll disappear as well. And on the other side I have 6 by minus 3 squared minus 19 by minus 3 minus 6. So be careful, you have to sub into the right hand side as well. Right, okay, so what am I left with? Well, I'm left with b minus 5 there. This is all multiplied together, so even though I'm putting a space, don't think that don't do this, but that's what I'm trying to say. Minus 7. It doesn't make, you forgot that there's multiplication going on here. Minus 5 minus 7 equals, right, so I need the calculator for that there. So 2 seconds, sorry, I'll bring up the calculator here now. Right, there I go. So I want 6 bracket minus 3 3 squared, it's taking us a bit slow here for some reason, minus 19. Now if I that's a bit why is that anyway, 2 seconds. Right, minus 3 bracket minus 6. Okay, be careful with the sharp Casios. It's not as easy as that in the sharp. You have to be careful what button, what minus button, because there's another, the sharp people see this button on there, and that's what they need to press sometimes for their minus 3s in the brackets. Anyway, equals, and I get 105 there. Okay, there it is, 105 in the red, 105. Okay, so underneath that, and while I was at it, I mean, minus 5 by minus 7, if you're not sure, minus 5 minus 7, don't know why that's so slow, anyway, equals 35. Right, so I've b by 35 equals 105. So B, that's 35. It's not being added to B, it's been multiplied by B. So when you take a number to the other side, you do the opposite operation. If I think of the operation there as multiplication, so on the other side the opposite is division. So it's 105 divided by that bracket, 35. And the good thing about writing it like that is both calculators they should be happy enough with that expression, divided by 35. Yeah, and I get a 3 there. Okay, right. Sorry, I don't know why that's slow. Anyway, right, B equals 3. Right, to start the whole thing again, I need to get rid of, I want that bracket to disappear that time. How will I make that happen? Sub in 4. So the choice there isn't that difficult this time. Let x equals 4. Who else is going to go? That's going to go as well. So I'm only left with, this is the only term now I have to worry about. That term's going to survive. Right, so I'll have c by 4 minus a 2 and a 4 plus a 3 and equals 6 by 4 squared minus 19 by 4 minus 6 again. Sorry for the bad writing. Right. Okay, so I'll again go to the calculator if you want there, but I'll have c 4 minus 2 is minus 2 by a 7 there equals calc again 6 by 4 squared minus 19 by 4 minus 6, away we go, equals 14. Again, just take your time. Minus 2 by minus 7. Throw it in again. I know some people say, yeah, we know this one, but anyway, just again, because this is what I said. It's great when you have this calculator. You don't even have to. If you don't trust yourself with plus or minus, it's just type what you see, and you see that, and you type it, and you get minus 14. The only thing is, you have to remember, it's not, you can't get away with everything with the calc. You have to remember it's not c minus 14, it's c times minus 14. Right, when I take that minus 14 across, I divide by it because it was multiplied on that left hand side, so it's been divided on the right hand side. Minus 14, do that in the calc again, 14, whoops, divided by bracket minus 14, minus 1. So you can barely go wrong with the calculator. Just make sure you're just doing it carefully. Right, final one, I need to get rid of the that bracket gone. There's the final bracket to be got rid of, so I'll need to sub in a 2 to get rid of that fella there. So let x equals 2. Now everything's gone again. What I'll do is I'll just take this. You don't have to do this because you have space. I have no space. I'm going to take this down with me. There we go again. So I'll just do, Ash will do red, or what will we do? And it hardly matters. Right, okay, so this fella, concentrating on him this time, let x equals 2. Okay, so that's going to go, and that one's going to go. So I'm only left with, this is the what I'm left with. A by a 2 plus 3 by a 2 minus 4 equals 6 by 2 squared minus 19 by a 2 minus 6. A by 5, 2 minus 4 is minus 2 equals, one more time over here, 6 by minus 2 squared. Oops, that's not a minus, it's a plus 2. Anyway, 2 squared minus 19 by a 2 minus a 6 equals minus 20. Okay, so again, just take your time with it. That's a minus 10 there, minus 20. Divide on the other side, minus 20 divided by minus 10. Type what you see in the calculator. Minus 20. Again, it's very easy with the Casios. It's just to be now, look what I'll have to do that again, because when there's something previous in your screen and you press minus, what comes up the first time is ants comes up. Anyway, right, so just make sure that what you intended to type in is coming up on the screen. Minus 10, I'll get 2 equals 2. Right, so what I'm going to do now, I found my A, B and C, so what I'm going to kind of do is, I'm just going to restate that. So what's happening is, this old fraction can be written like that new fraction, that split up fraction with A, B and C on top. But you're going to restate you're going to basically restate that statement there, but you're going to state it with the values of a, b and c that you just found above, subbed into it. Right, so the original fraction, which was, again, it's gone from the screen, but you have your I put that sample for YouTube exam paper up in web courses, have it beside you and look at it. So, but your fraction was this. So that, and you don't be afraid. I'm going to use a little symbol there. That's the math symbol for the English. This means, or that means. This means that the old fraction 6x squared minus 19x minus 6. The bottoms were this here, x plus 3 by an x minus 4. Equals a over the first factor in the bottom. You got a was a 2. There's my 2 over the first bottom, plus b over the second factor. B was, if we look up here, b was a 3 in the blue. Anyway, that doesn't matter. 3 over the second bottom, x plus 3. Finally, plus c, which was a minus 1. And what I'll do, I'll just keep it, I'll still say plus, and she'll put that minus 1 up there on top of that fraction over the third bottom. Right, so you're not done yet, because you were asked to integrate this guy here. So this is what I'm going to do now. I'm going to write down that the integral, so that means that the integral of this here, so it feels now like I'm writing this down a lot of times, but I'm afraid you have to, minus 6 over x minus 2 by x plus 3 by x minus 4. And I'll just, kind of argue it well, and we'll say, right, well, the integral of that, and again I'm going to do that in red just to highlight that, think of the dx comes hand in hand with that swirl integration symbol. They appear together, and what you're doing is you're being asked to integrate the blue expression between them. Anyway, right, so the integral of that original fraction must be exactly the same as the integral of these individual fractions. So it's the integral of 2 over x minus 2 plus 3 over x plus 3 plus minus 1 over x minus 4 dx. Okay, but functions separated out with plus or minuses can be integrated separately. So that's what I'm going to say next. Well, sure, all those can be done separately. So that's the integral of this single fractions on its own. Now again, because the dx comes with the swirl symbol, I have to write it now every time if I'm doing that split, plus the integral of this fraction on its own separately. Dx again, you can't, it doesn't, you're not doing it, you're not writing the thing correctly if you don't write in the dx each time, plus the integral of that little fraction on its own separately, x minus 4 dx. Right, so after we done this in the integration notes, we said you can say that we kind of covered those in the, we put these in as notes after we done substitution and that big integration handout notes, and we said, well, it would come in handy if you just memorized those guys there and said, right, well, so what I'm really, to get to the point of the story, I told you that I'm making you memorize these here. Because we argued about them in class, and we said, well, the integral of 1 over x plus or minus any number dx is the ln. Now this is a thought, so this is a thought now, right? And the thought's going like this, that the integral of 1 over x plus or minus number in the bottom, we said, well, if you use a bit of substitution, it would be a v in the bottom, and the integral of 1 over v is ln of v, but you would have ended up with this anyway. I'm picking too many colours here. If I would have written down, if I just use a single colour, it's the ln of that bottom fella, because then that's what you would get when you sub the v back in anyway. And the dv dx part for that was a 1. So that'll get me out of that. Now you say, well, what happens when it's not a 1 in the top, if it's something else? Yeah, if it's something else, if it's a 7 there, I'm just going to overwrite that and say pretend it's 7. Whatever's there will appear outside there, because I could have popped it out of the integral anyway in the first place and then put it back in at the left. Right, so each of those guys can be done using that little rule. So I'll say, well, that equals 2 times the ln at the bottom there, x minus 2, plus 3 times the ln at the bottom there, which is an x plus 3, plus minus 1, which becomes minus 1 anyway, ln of, now I have a problem here because I want to minus the ln of x minus 4. That's bad writing, sorry about that. Right, when I integrate, there is no limits, so I add on the plus c at the end. Don't forget about that plus c, because there are no limits. If there was little limits there, you would find them individually, but we don't have limits here, so put in a plus c at the end. Right, that's it then. Sorry for the bad writing. End that. Stop. Yeah.